All right, so get ready, because today we're diving into a topic that sounds kind of complex, maybe even a little intimidating.
Yeah.
Epigenetics.
That's a mouthful.
It is, but I promise you, it is absolutely fascinating and way cooler than the name might lead you to believe.
Oh, for sure.
We're going to be talking about how it's not just your DNA that makes you you, but also your experiences.
Exactly.
And get this, potentially even the experiences of your parents and grandparents.
Oh, yeah, we're going there.
Like, how crazy is that? We'll be looking at some wild examples, like studies on the grandchildren of famine survivors.
Some really interesting stuff.
Yeah, so if you're ready to have your mind blown wide open, buckle up, because we are about to go deep.
Let's do it.
So let's kick things off with the basics.
Okay, sounds good.
What exactly is epigenetics?
Well, think of it this way. Your genes, they're like the blueprint for building you, right?
Okay, yeah.
But you need someone or something to read that blueprint and tell the builders what to do.
Like a foreman on a construction site.
Exactly. And that's where epigenetics comes in. It's like the foreman of your genes, controlling which ones get expressed and how much.
So it's not about changing the actual DNA sequence itself.
Right. It's not about rewriting the blueprint. It's more like adding little notes and instructions on how to read it.
So how does it do that? What's the mechanism behind all this?
Well, there are a couple of key players here.
Okay.
One is called methylation.
Methylation, all right.
And it basically acts like a dimmer switch for your genes.
A dimmer switch, I like that.
Yeah, it attaches this little chemical tag, a methyl group, to a gene and kind of tells it to quiet down or even shut off completely.
Wow, and that's just from adding a tiny chemical. That's wild.
It is, and then there's the opposite, acetylation.
Okay, so that's the turn it up to 11 switch.
Pretty much, it adds a different tag, an acetyl group, and that one tells a gene to be more active.
So we've got our dimmer switch and our spotlight.
Exactly.
And just these small tweaks can have a big impact on how our bodies work.
Absolutely, it can affect everything from our physical health to, get this, our intelligence.
Okay, hold on. Intelligence. Now that's where things get really interesting.
Right, because we always think of intelligence as being determined by our genes.
Nature versus nurture.
Right, but epigenetics throws a whole new wrench into that debate.
So are you saying our experiences can actually make us smarter or, well, less smart?
It's not quite that simple.
Okay.
Intelligence is incredibly complex. It's influenced by a whole network of genes and countless environmental factors.
Yeah, but there's got to be some connection to epigenetics, right?
There is, and studies are starting to uncover some fascinating links.
Like what?
Well, for instance, they found that certain methylation patterns in specific genes are correlated with cognitive performance and learning ability.
So even if you inherit a set of smart genes, if your environment isn't supportive, those genes might not reach their full potential.
Exactly. It's like having a Ferrari, but never taking it out of first gear.
Wow. Okay, so that's mind-blowing enough. But then we get to this whole other level, transgenerational epigenetics.
Now we're going down the rabbit hole.
Right. This is where it gets really sci-fi.
It does, but it's also where we see just how powerful epigenetics can be.
So for those who are hearing this for the first time, what is transgenerational epigenetics?
It's the idea that experiences, especially traumatic ones, can have an impact on the genes of not just you, but also your children and even your grandchildren.
Like your grandma's experiences could be affecting your genes today.
It's wild, right? And while it's still being studied in humans, we've seen clear evidence of it in plants and insects.
I remember reading about a study on famine survivors.
Oh yeah, that's a classic example.
Their grandchildren, who had never experienced famine themselves, had lower IQs on average.
Exactly, and that suggests that the trauma of the famine might have led to epigenetic changes that were passed down through generations.
That's incredible, but I imagine proving this kind of thing in humans is incredibly difficult.
Oh, absolutely.
I mean, how do you separate genetics from upbringing, culture, all those other factors?
Right, and ethically, you can't just go around subjecting people to trauma to see what happens to their grandkids.
Yeah, no kidding.
So it's a real challenge, but researchers are working on it, trying to tease apart all those variables.
It makes you wonder, like what kind of impact are our own experiences having on future generations?
It's a big question, and I don't think we have all the answers yet.
But this whole concept of epigenetics, it really changes how we think about our own potential, doesn't it?
It definitely does.
It's not just about the genes we inherit. It's also about the choices we make, the environments we create, and how those things can shape not just our lives, but the lives of those who come after us.
That's the beauty of it. It gives us a sense of agency, of responsibility even, knowing that we can influence our own well-being and maybe even leave a positive mark on the world that extends far beyond our own lifetime.
It really makes you think, doesn't it? Like, what kind of environmental switches can we flip to improve our own lives and maybe even give future generations a better chance? It's definitely something to ponder, and that's where we'll leave you today.
Until next time,
Take care.
see ya.
Bye.